All right, so these say, well, the directions on 10 says, use the slope of the line and the point on the line to find 3 additional points through which the line passes. For 10, it says your slope is 0. So what kind of line has a slope at 0? Horizontal. So that means you're moving left to right. So when you get this first point, 2, 1, 2, 3, 4, 5, no matter where you go to the right or the left, what do you notice about the y value? It stays the same. So you were basically looking for your set of points in which your y value did not change. Does that make sense? So if you look at that fourth option, they stay the same. For the other one where your slope is 4, I would almost recommend putting this on an actual coordinate grid so that it's easier to spot those points. If not, then you just got to be really careful and pay attention to where you're plotting the points. If it said that you're starting at -5, 2, you're starting here, and then your slope is 4, which means it's 4 over 1. That means your change in y is 4, so up 1, 2, 3, 4, and to the right 1. Or you could reverse that, down 4, and to the left 1. So those were points, but there's also a pattern happening with your values. You're going up 4 and to the right 1, which means your x is changing by 1 and your y is changing by 4. Like if you wanted to look at it that way, and the only one that works that way is this. So I would say either do your actual plotting of the points, count up 1, 2, 3, 4, and to the right 1. Because if this was a test in which there was a question like that, it probably wouldn't be multiple choice. You just have to give me those values. Does that make sense? Yeah. Okay, so 2(1)b is now writing the equation of the line. So we're flipping it. Oh, yeah. All right, so we're going to start with the 3 different approaches based on what you're given. If you are given the slope and the y-intercept, you literally can just plug them into the y, into the m, into the b in your y equals mx plus b. So if I give you slope is 2 and the y-intercept's -3, you literally just put them in those places. Done. Okay, that's the easiest. If you're given the slope and the point, then you have 2 options. The first option is to plug the point, which would be your x1 and your y1, and the slope into m, into point slope, which is y minus y1 equals m times x minus x1, and then solve for y. The second option is to plug the point into the x and the y, and the slope into the m of y equals mx plus b. For that one, you'd have to solve for b, and then you'd have to plug back in the b and the m. So you're going to plug it, solve for b, and then plug the m and the b back in to y equals mx plus b. So I'll show you one of each of those examples. You get to choose which one, okay? I typically choose the first one, but it doesn't mean you always have to. And then the last one is what happens if you're given 2 points. If you're given 2 points, the first thing you have to do is find the slope and then grab that slope and either one of the points and do option 1 or option 2. In the bottom, note that it says, unless otherwise stated, answers should be in slope-intercept form. So when I go to write out my answer, it should be in y equals mx plus b form, unless it says differently. If it says put it in point slope, you put it in point slope. If it says standard, you put it in standard. But the default is y equals mx plus b. All right, so let's look at number 1. What am I given? The slope and the y-intercept. So this is my m and this is the b. Y would equal 3x plus 5. Simple as that. Two gives you the point and the slope. So I'm going to do this one with point slope and I'll do the next one the other way, okay? So this would be my m, this would be my x1, y1, and I'll do y minus y1 equals m times x minus x1. Point slope. So the y stays as a y. The y1 is 5. The m is -2. The x stays as x. And the x1 is 4. So it's -4. So I plugged in the m, the x1, and the y1. And then I got to get it into slope-intercept. So I'm going to distribute here. I'd get y minus 5 equals -2x plus 8. Add the 5. Y equals -2x plus 13. Questions on that one? All right, 3 says the slope is 2/3 and it passes through negative 1, 2. So this time I'm going to keep this as my m because that's what it is. I'm going to make this as my x and my y, and I'm going to plug it into y equals mx plus b. So y equals mx plus b. The y is 2, the m is 2/3, the x is negative 1 plus b. Multiply the 2/3 and the negative 1, I get negative 2/3 plus b. And my goal here is to solve for b. So I'm going to add the 2/3. I have to give this a like denominator, so this would be times 3 and 3, so it's 6/3 plus 2/3, which is 8/3. With me so far? So that's the b. Now I plug back in the m and the b. So y equals m, which is 2/3, x plus b, which is 8/3. Sometimes I flip-flop back and forth between them. I don't like having to plug back in, so I typically do point slope, because once you plug it in, you just got to solve it, you're done. But some people are much more comfortable with y equals mx plus b form, so do it. It's completely up to you. Yep. Mm-hmm. You're welcome. All right, so 4 now says passes through 2, 4, and 5, 6. So what's the first thing I have to do? Good. I got to find this slope. So it doesn't matter which ones you make the x1 and the y1 and the x2 and the y2 as long as you're consistent within the parentheses. But then I would get 6 minus 4 over 5 minus 2, and I get 2/3. That's my m. And then I can pick either point, okay? And it doesn't matter. I would say if there's a point that has negative signs and one that doesn't, pick the one that doesn't, because we tend to make silly mistakes when we start to minus negatives. Both of these are positive, so it really doesn't matter. I'm just going to grab the first one. And I'm going to plug it into point slope. So y minus y1, which is 4, equals 2/3 x minus x1, which is 2. Distribute your 2/3. Y minus 4 equals 2/3 x minus 4/3. And then add the 4. Y equals 2/3 x, and then I got to do negative 4/3 plus 4 over 1. Change my denominator. And I get 8/3. You can see these like rewritten, like instead of it being 8/3, it could be 2 and 2/3, okay? You won't ever see them in a decimal that's rounded, so be careful unless it like absolutely terminated. But my preference would be to keep it like that. Just make sure it's reduced. Do you ever need to check it? No, there's not like any extraneous roots or anything like that. Questions on any of these? All right, now we've got our special cases, right? Because 5 says a horizontal line passing through 4, 7. So think about what you know about a horizontal line. Slope is 0. What variable is in the equation? It's a y equals. So I don't even look at the x. I just grab the y. You could make slope equal to 0, and I could say y minus 7 equals 0 times x minus 4. I could distribute the 0. It's gone, and I could get y equals 7 the long way around. Still gives me the same answer. But you cannot do that with undefined, right? Like I can't plug in undefined. So I have to know that the vertical line is what? X equals, and then I just grab the x value. So it's x equals negative 1. All right, then we get the relationship between parallel and perpendicular lines. So parallel lines have the same slopes. If I have a line that is parallel to the first line, I keep the slope the same. Perpendicular lines have slopes that are opposite reciprocals. So if the slope of my first line is 2/3, what's the slope of a line that is parallel? Those two bars means parallel. What's the slope of a line parallel to that? 2/3. What's the slope of a line that's perpendicular to that? -3/2. So we change the sign, we flip the fraction, okay? What if it started as -2? Parallel to that would be what? -2. Perpendicular to that? +1/2. So change your sign and make it the reciprocal. Okay, so now apply that to the equations. Find the equation of a line with the given information. 7, the first 7, because there's 2. The first 7 says find the, that A parallel to and B perpendicular to 2x minus 3y equals 5. That passes through 2, -1. So there's actually 2 questions in this one. A, where they're parallel, and B, where they're perpendicular. So if it's perpendicular to this line, what do I need from that line? Just its slope, which you can find 2 ways. What's one way? Say again. I could get it into I could get it into slope-intercept, right? So I could rewrite this so that it's -3y equals -2x plus 5, divide everything by -3. Y would equal 2/3 x. I don't even need to finish it off because the 2/3 is what I need. Do you remember your shortcut? -a over b. So a is the 2, b is -3. -2 over -3 is 2/3. Same answer. One takes a little bit longer than the other, but if you don't know the shortcut, don't mess it up. Just solve for y. Yep. When it's in standard form and you want the slope. Only when it's in standard form. So x and y on the same side. Yeah. Okay, so so now I'm done with this, and that's the biggest mistake people make is they grab that, they also take the b out of it. You are done with that equation. The only thing you want from that equation is its slope. Now I go to my question that says find the slope of a line that's parallel to that passes through 2, -1. So what slope am I going to use? +2/3, and the point is 2, -1. And then you could plug it into point slope or slope-intercept. So y, yep, sure. Y minus a -1 would be y plus 1 equals m, which is 2/3, times x minus the x1, which is 2. Distribute the 2/3 and then subtract the 1. This would be 3/3, and that's -7/3. Questions on that one? Okay, so now I go to B, and for B, I want to know a line that is perpendicular to that first one. So what's my slope? -3/2, good. But I still use the same point. So y minus a -1 becomes +1 equals m, -3/2 x minus 2. Y plus 1 would equal, distribute this. This cancels, so this would be 1, and I get +3. Subtract the 1. Questions on that one? Yeah.
Would it be okay to use an endpoint? Like if the slope is...
Like if you find another point, you mean?
Yeah, or no, like when you write the perpendicular slope, or perpendicular equation, wouldn't it be fine to use another point?
Well, they're only going to give you that one point. Is that what you mean?
No, like instead of using 2 as the y-intercept, yeah. What if I put like 7?
You'd have to then figure out what the corresponding point is for that. So you can't just pull a point. Is that what you mean?
Yeah.
Yeah, you can't just pull a point unless you counted from 2, -1, unless you counted down 3 into the right 2, you could use that point. If not, you just want to grab the first one. The other mistake is that people make is that they finish this first part and then they grab this b and reuse it with your perpendicular slope. Totally wrong. There's no relationship between those b's. So be really careful. The only thing that really should happen at the end is the relationship between the slopes. They should be opposite reciprocals. But there's no relationship to the b's. So don't reuse it. Yep.
How'd you get -7
From here?
Yeah.
So once I got the slope was the same, right, which is 2/3. I plugged in my slope and my point. So I plugged in a point slope. Y minus a -1 becomes +1 equals 2/3 x minus the x1, which is 2. And then I distributed the 2/3. Distribute this, and I get -4/3. And then subtract the 1, and 1 is 3/3. So y equals 2/3 x minus 7/3. All right, not last one, sorry. Second 7. Is A parallel to and B perpendicular to 5x minus 3y equals 8? That passes through -4, 1. So completely the same kind of question, different numbers. But let's see if we can use the shortcut. What's the slope of this? So this would be A, right? It's -A over B. So it'd be -5 over -3, which is 5/3. So what's the slope of a line that's parallel to that? Nope, parallel. Same, 5/3, and then use this point. B perpendicular would be -3/5, and then -4, 1. So I'd get y minus y1 equals m, which is 5/3. X minus a -4 becomes +4. Distribute the 5/3, so y minus 1 equals 5/3 x plus 20/3. Add the 1, and y equals 5/3 x. This would be 3/3 plus 23/3. Do it again. So B, same process, but we're using the reciprocal, the opposite reciprocal because it's perpendicular. So y minus y1 equals m, -3/5. X minus a -4 becomes +4. Distribute the -3/5. Add the 1. Y equals -3/5 x. This would be 5/5. So minus 7/5. And then, this should be 9. Rewrite the answer from those equations in standard form. So I'm going to start with this first one. What makes an equation in standard form? What are the rules for standard form? X and y the same side. What else? Are you allowed to have fractions? No, no fractions, no decimals, and x has to be positive. So what if I wanted to get rid of those fractions, what would I do? Good. So I'd get 3y equals 5x plus 23. And I want the x to be positive, so I'm going to move the y and the 23 instead of moving the x. So I'm going to subtract the 23 and subtract the 3y. On the left would be -23 equals 5x, this is gone, minus 3y. That is standard form. So no fractions or decimals, x and y are on the same side, and x has to be positive. Do the same thing with b. How do I get rid of the fractions? Multiply everything by 5. X and y same side, x positive means this time I'm going to move the x.